Yowzers, lots of stuff going on when it comes to space weather. So let's get right into it here at the Smash News Network. These Busted Name of News. We're going to go deep into space, a frontier. These are the voyages of the SDO. And there are dozens of large filaments suspended in the solar corona by magnetic fields, defying solar gravity, and creating the possibility of additional coronal mass ejections. Now, NOAA is forecasting one to strike Earth. We said we didn't think it was earthly directed. And disagreements in science are what it's all about. So let's go in depth and bring you the most detailed solar imagery and comprehensive space weather you'll find in the known universe. So we're going to go around the horn here. We're not just going to look close. We're going to talk about specific features. And there are a ton of filaments. You can see some of them around here. Some of these dark absorption features are solar filaments. Up here in the northeast, we've got a new sunspot. So it did produce at least one M-class flare there. It is already a beta-gamma class sunspot group. I believe it is a returning sunspot group. I don't keep track of the numbers. I'm not hung up on that. I don't really care what the numbers are. Here is the northwestern limb. We've got some spontaneous plasma reorientation happening right here, right at the end of the video, right there. A little spontaneous flare happening there. Sometimes we see solar flares without even sunspots or active regions, often because of plasma filaments splashing back down onto the solar surface. Here's your southwestern limb view. The Patrick Stewart filament there right behind the Earth scale imagery. And thanks to our viewers who've named filaments after living people on the Twitter feed. Here's your SDO intensity gram yesterday plus today. Again, you'll see this rather large beta-gamma class sunspot group rising right up here in the northeast. And here's your colorized magnetogram. And I would say now the most likely spot to see major solar flares would indeed be this. Hang on a minute. What the hell is that supposed to be? All right. Geez. Okay. Let's try this again. We're going to simply try to draw something with Epic Pen here and see how that works. If that works. The most likely place to see solar flares, in my opinion, is now up here in the northeast, as that is a large group right on the limb. And before we get back to space, let's take a moment to look at Croissant Earth. So we're always interested in what volcanoes are erupting. Sakurajima is producing an 8,000-foot ash plume as it explodes. Also, Suwanosejima, 7,000-foot ash plume over Suwanosejima, flight level 070. Karengatang continues to explode here, 8,000-foot ash plume, flight level 080 over the Sangihe Islands of Indonesia. Siau Island. Karengatang. Carinci also exploding, producing a 13,000-foot plume of volcanic ash. Please do not pole vault the caldera. Central Mexico features one of the prime suspects, Popocatépetl. Popocatépetl exploding, flight level 200 is a 20,000-foot volcanic ash plume. Headed down to Central America to Guatemala, Fuego is exploding. 18,000-foot ash plume from Fuego. 20,000-foot ash plume from Nevado de Ruiz in Colombia. Not sure about Sangre, but Cotopaxi and Revenador have dispersed their ash, and we're still seeing intermittent emissions from Sabancaya in Peru. Let's take a look at seismicity next. So we did have one significant earthquake here in the past 24 hours. It was a 6.1 magnitude quake at the Philippines. There is a location of that. We'll zoom out there to show that spot there in the Samar Sea. Kind of right in the middle of the Philippine archipelago there. That one came in at 1810 Universal Time yesterday evening. So a bit of an earthquake uptick since yesterday. We had a 5.2 in Colombia. We had a 5.0 north of on the North Island of New Zealand, off the coast of the North Island of New Zealand. Tonga had a 5.1, and that was only 10 minutes before this 6.1 in the Philippines. Also, Bolivia had a 5.0. And then a lull in 5+ magnitude quakes until Vanuatu had a 5.6. That was at 5:37 Universal Time this morning. Haiti had a 5.5. And Philippines also had a 5.0. That was northwest of that 6.1 magnitude quake. Let's get back to space first. Take a moment to press like. If you haven't pressed like, the likelihood of us producing a live stream on YouTube goes down. Thanks for leaving a comment, Tinman1057. And yeah, if we see 50 likes on today's daily space weather video, we will do a live stream on YouTube. Yesterday's video featured 49 likes, so not quite doing it. And if you want to support the channel, please do so with a subscription to smashomash.com/smashteam. There's a gold level, there's a gold annual paid-up subscription, there's a silver level, there's even a bronze level for all of you folks out there unable and or unwilling to open your cobweb-encrusted wallets and send us a few bucks a month to produce the content. We also send out email alerts, so log in and click posts at smashomash.com/smashteam to see the latest posts for your level. Today's featured product is the Galactic Federation Special Forces motto, the tagline of the Galactic Federation Special Forces, which is in Latin, as Special Forces taglines tend to be. And I say to each of you, Universum Liberate. If I could wave my magic wand, I'd set everybody free. That's a quote from Rush, one of my favorite bands. Not sure if Geddy Lee or Neil Peart or perhaps even Alex Lifeson wrote those lyrics. But if you're sick of what's going on in your city, county, state, country, hemisphere, planet, solar system, move out to the galactic scale and join the Galactic Federation Special Forces. And tell your friends and foes about this fact with some Universum Liberate merch. The symbolism features a spiral, which is a symbol of the Milky Way galaxy itself. The key represents signal strength, integrity, and security. The lightning bolt represents instantaneous galactic scale reach, and this little bright spot up here represents, well, that's classified. But in any case, support the Galactic Federation Special Forces and your desire for freedom and liberty and personal responsibility with our Universum Liberate merch. If you click the links below the video, or on the homepage at smashomash.com, you'll find our products in order of best selling, so take a look at those. If you haven't, check them out. And congratulations on surviving a global scamdemic so far. You're doing a fine job. Congratulations on not being dead. Here's the past 24 hours in SDO 171 angstroms. So that's one of our favorite wavelengths. Let's add 131 angstroms. Once again, the most likely place to see large solar flares, in my opinion, is now this new rising beta gamma class sunspot group right up here. It's already produced at least one M-class flare, I believe. And let's continue on to take a look at the 10.7 centimeter radio flux, which is now all the way down to 174 solar flux units. Now that radio signal comes out of the upper chromosphere and lower corona, this area right about here. And for you new viewers, that is a proportional data set to sunspot number. As you can see on this Solon.info convenient one-year graph, the red line there is a sunspot number, the black line is the radio flux. And of course, there are various different features of solar activity that tell us what's going on with the solar cycle. And we are seeing strong magnetic fields here and some geomagnetic storm conditions to continue for days. We'll tell you why here in just a moment. So, we've got a very strong magnetic field, first of all. So if you look at this stat right up here on the Space Weather Enthusiast dashboard, the current BT is 18 nanotesla. So the north polar region, the north magnetic pole of the sun here, a little bit stronger magnetic field than the south, as that is quite a strong field, and we do have a significant negative BZ component there. The vertical component of that magnetic field, negative 6 nanotesla, and it could be getting even stronger here. So we are expecting geomagnetic storm conditions to continue with the rising of the solar wind speed. So also, NOAA forecasting some coronal mass ejection impacts here late in the day tomorrow, the 17th, and early in the day on the 18th. So we'll show you the quick animation here. This is the animation of the NOAA CME impact forecast there. Expecting to see an increase to about 550 to 600 kilometers per second there from that CME. And as you can see here, it is showing it off to the east a little bit. We think it's going to miss entirely to the east and south. But if everybody agreed, science would be a boring place. So anyway, that's NOAA's forecast. And we can expect an increase in the sunspot number and the radio flux today with the rising of that new sunspot group. So here's the Enlil spiral also showing this CME impact. You can see here also it is off to the east and south a little bit there. That is the CME forecast. And I think this might not even, I think this will be a nothing burger. Although NOAA is expecting this to be a KP6. So a G2 class geomagnetic storm expected by NOAA here early in the day on the 18th. Current conditions are geomagnetic unrest to geomagnetic storm conditions. Current condition is KP 4.33, certainly geomagnetic unrest. And we're seeing the high-speed component of the coronal hole high-speed wind show up. So here's Earth's magnetic moment from space for the past 4 hours. It should be. And quite high pressure environment there in terms of magnetohydrodynamic pressure. That's our geospace magnetosphere movie. Here's our ground magnetic perturbations map, and we're expecting to see lots of aurorae. So make sure you follow us on Twitter. For that reason, we'll be sharing auroral imagery. We follow lots of different accounts over there. Highly recommend you follow Scott McIntosh, who does things like create actual forecast models for solar activity. Anyway, that's the last 4 hours of Earth's magnetic moment from the ground. You can expect to see a lot of aurorae. Here's our Aurora 30-minute forecast, and yeah, you can expect to see lots of auroral imagery here for the coming couple of days. And since that auto-refreshed for us, we'll let that play through. And of course, you can share your auroral imagery if you've got your own. Hit us up on, especially on Twitter. You can also send a message on Instagram. And links to those sites are all located below the video and on the homepage at smashomash.com. And welcome to the Neo Renaissance. So looking at the real-time solar wind here, we see a strong magnetic field. It made it all the way up to 22 nanotesla as we saw the transition from the high-density solar wind to the high-speed solar wind. So that's a typical feature of coronal hole high-speed streams, folks. We typically see this feature right here. You see the density coming down and the speed coming up, often accompanied by an increase in the plasma temperature as well. And this top pane is the real pain to focus on here because we've got, oh wow, we just saw a very strong negative BZ component there. So we may go into KP6. Just right from KP 4.33, we could go straight to KP6, maybe even KP7 if we see the solar wind speed continue to increase here with this as well. Current conditions are 18 nanotesla for the solar wind, for the magnetic field. 18 nanotesla, and a negative BZ of negative 16, a very, very strong negative BZ there. That induces a lot of current in the Earth, so we could see major, significant geomagnetic storm conditions if that sort of signal continues. Current solar wind density is still elevated here as well at 13 protons per cubic centimeter. And solar wind speed here, we're expecting this to continue to uptick. So we may see even a KP 6.5, KP 7, something like that. This is a significant coronal hole high-speed stream. So lots of stuff going on in terms of space weather. It's a major uptick in the earthly portion of the space, the Earth end of the space weather, despite a little downtick in the basic sunspot activity for the past couple of days. So let's move to magnetic data here. There goes magnetometers, and you see those sawtooth readings. No surprise to our regular viewers there who would have expected to see that during a coronal hole high-speed stream. And looking at the top view, ecliptic plane field plot, Earth is right in the middle of the North Pole. So you bring up the latest image. There you go. There's the north. This is the North Magnetic Pole. And this is the South Magnetic Pole. And Earth is right in the middle of the North, which is looking kind of strong, as we're seeing strong magnetic fields detected at Lagrangian point 1, which is about 1 million miles between the Earth and Sun there. Keep in mind this imagery is not to scale. And let's look at our line of sight plot. You can see the B field all fanned out there because, again, we are currently in the North Polar Magnetic Field. Welcome to the North Pole, the North Magnetic Solar Pole. You're currently in it, even if you're in space. Next, our line of sight field plot, our line of sight coronal hole plot, rather. And there you can see a bunch of North Pole-oriented coronal holes showing up there. At the current moment, no South Pole-oriented coronal holes. So all the coronal holes you'll see in this 24-hour SDO imagery, they're all North Pole-oriented. So that's North Pole, that's North Pole, this is North Pole, this is North Pole. So again, welcome to the North Solar Magnetic Pole. You're right in the middle of it. Also, we can expect another coronal hole high-speed stream from this one. It is a trans-equatorial coronal hole. Those are the most geo-effective type. And let's move on to another important feature of solar sunspot cycles. The ever-popular sunspots. So, we are expecting a new sunspot to get named here. This will certainly get a name later today. That'll be sunspot, what is the next region? 32, is it 3230? I can't remember. Anyway, I don't get hung up on the numbers of sunspots. That's kind of irrelevant. The physics is a lot more important. And anyway, likelihood of large flares is certainly there. It goes up with the rising of this new sunspot in the northeast. So let's take a look at the last 24 hours from SDO Continuum. And those are mostly stable there. So we can expect a little uptick in the sunspot number and the radio flux with those large rising groups in the northeast once again. And let's move on to energetic particles. We ain't got none. The ghost proton flux here is flatlined. No relativistic particles. And we've had some M-class flares. This one, most recent one, was a long duration C9.02 class flare. And let's take a look at some activity there. By the way, that C9.02 flare is from this region up here. A prime example of plasma splashing back down and creating a solar flare. So that's 304 plus 94 angstroms. You can also see that M-class flare coming from the northeastern limb. Here's 94 plus 131 angstroms. And next we'll talk CMEs. That stands for coronal mass ejections, by the way. But before we do that, let's take a moment to orient ourselves. So this is what's going on overhead in Lehigh Valley, Pennsylvania. The sun just a few degrees off the horizon there, and Saturn practically in line in terms of east and west, just to the south of the ecliptic there. Mercury rising ahead of the sun. If you are up before dawn and have a clear horizon and low light pollution, you may be able to see Mercury. Here's your solar system forecast. We've got Saturn at conjunction or opposition or whatever it's called. Let's advance this 1 week. Here's where things will be in a week on this lonely side of the solar system, devoid of gas giants. In 1 week, we will have a crescent waxing moon. And let's take a look at some coronagraphs. So yesterday, the CME that's forecasted to strike Earth occurred, and I'm just not seeing that this is going to be an Earth strike. I don't expect it to cause any geomagnetic storm conditions. I would say that it might miss entirely, and if it does show up, it's going to be a weak signal, if any. But this is a normal thing as people disagree on space weather, and that's how the science advances. I don't see a halo that looks like it's off to the southeast to me. That's 91 frames from yesterday. Here are an additional 27 frames from today. And let's take a look at some more in-depth information here. So here's stereo A on the left. And unfortunately, there's a bunch of missing data there. There's a very recent CME happening here in the past couple of hours. So there's that one. We'll pause it right there. That's the last frame we've got anyway. And here is today's imagery from the Soho Lasco C3. So that one looks like it's off to the northwest. Keep in mind there is a separate event happening here from the south, sort of on the opposite side of the sun. So again, not earthly directed. And here are our 24-hour custom videos. So that'll include yesterday plus today. That's 24 hours from when we create the videos. And yeah, I'm just not seeing the halo from that. Let's get a little closer. And how about even closer? There we go. There's SDO 304 angstroms plus the Soho Lasco C2 in red and C3 in blue. And next, let's talk filaments. And talk about a lot of filaments. There are more than I would like to count. If you'd like to name filaments, once again, join us on Twitter. If you don't have an account, create one. If you think the censorship is fixed, snap out of your delusional realm. Elon did not fix anything on Twitter in terms of censorship because the deboosting features, otherwise known as shadow bans, continue. However, if you would like to name filaments after living humans, you're invited to do so. Let's bring up the latest image. Here's the Patrick Stewart filament. That's the only one that's got a name, I think. So there's lots to be named here, like this one up here, and this one here, and this one here, and this one here. And what about this one? How about this one down here in the south? What about this one in the northeast? That's a lot of filaments. So anyway, likelihood of coronal mass ejection is nearly 100%. And once again, you're invited to name that filament. An important feature of space weather. And so we show off the filaments. Again, make sure you follow us over there on Twitter. There's lots of information you'll only see on Twitter. Also, we've started doing Twitter Spaces as well. So that's an upcoming feature of the channel. Twitter Spaces now coming to the Smash News Network, least busted name in news. Even though the pathetic, putrid, and disgusting censorship is very similar on Twitter, as it is to on Google sites like YouTube, and as it is on iTunes, and similar as it is to meta sites. It's utterly putrid and pathetic. However, if you intentionally view the Twitter feed, you may actually see the tweets. You may also see our pinned link. So we pinned our link to our free samples for our mushroom gummies. So our latest affiliate/sponsor is indeed Hemp Lucid. So if you want some free mushroom gummies, no credit card or shipping required, click the link on the Twitter feed. We pinned it for your convenience. And if you click the link below this video in the description, you'll see the link to our Hemp Lucid shop. So pick up your solutions for your sleep, immunological, stress, or focus issues. CBDs. There's also CBD body balms and lip balms and so on. Check out all of that. Save some cash by entering the promo code SMASHOMASH10 on checkout, or just simply shopping via our link. You can also find links on the homepage at smashomash.com, and welcome to the Neo Renaissance. We remain surprised that you've found the channel in the first place. So here's the past 24 hours in SDO 171 plus 335 angstroms. Here's the past couple of hours in GOES 16 SUVI 304 angstroms. Again, that latest C9.02 class flare came from right here. It's a great example of plasma splashing down. There's no real active region there. That is a plasma-generated effect, not the effect of a magnetically organized region, a plage or a sunspot. It's nothing like that. It's just a plasma effect. As that plasma succumbs to gravity, escapes its magnetic field, and crashes back down toward the chromosphere. Here's the full disk view. That's about the past 2.5 hours. And this brings us to our bonus features segment. So first thing we'll look at is satellite charging hazards, and we've got some significant surface charging here from Mexico into the Central Pacific Ocean. That's caused by low-energy electrons building up on the outside of spacecraft. Surface charging hazards here at the moment. North of the equator over the Pacific Ocean. The GOES electron flux here cratered. Very low levels of GOES electron flux as we forecasted. That's the past 3 days. Here, let's show you the cratering. There you go. That's typical of a coronal hole high-speed stream. And here's the forecast model, and I think we were almost exactly where we said it would be yesterday. Watch yesterday's daily space weather video if you didn't see the forecast. That was awfully close to where I predicted it to be. It's all about understanding the physics, folks. If you understand the physics, you won't sit around on YouTube and state a bunch of space weather nonsense. Space weather nonsense, very common on YouTube. Don't get drawn in. Here's the 1-year chart of the relativistic electrons. Those are measured by the GOES 16 and GOES 18 from their geosynchronous orbits. They use radiography to measure that signal down at the F layer of the ionosphere, which is what we'll show next. It's located at about 300 kilometers of altitude, and here's the vibrational frequency of that bridge between Earth and space. There's a lot of shaking going on up there. And of course, it tends to be concentrated around the equator at noontime. And it tends to show us major anomalies. And we are seeing major anomalies, both low-frequency anomalies around the pole and high-frequency anomalies around the equator. It might not be obvious from this imagery, the raw vibrational frequency, so don't worry. We'll show the anomalygram. That's anomaly in megahertz from a 30-day median. So again, huge low-frequency anomalies happening around the pole. Wild swings of high and low-frequency anomaly happening around the equator. And of course, the weirdest portion of the ionosphere is right here. The South Atlantic anomaly, which apparently our channel alone covered its movement since it moved from here all the way down to here, back up toward the equator, and then right back to where it was. That took a few weeks, but that's interesting indeed. Does it signal an end of the magnetic excursion or a continuation? Let us know in the comments what you think. Anyway, here's the latest image of the ionosphere. That's 12:30 Universal Time ionogram, and there's 12:30 Universal Time anomalygram. That data is courtesy of the Australian Government Bureau of Meteorology. We'll also show the total electron content. That is the free electrons from the inner portion of the outer Van Allen belt down to your GPS handset. A run of about 12,500 miles, and we're seeing huge and expected GPS errors around the world. So usually these are a little bit more concentrated around the equator at noontime. We're seeing huge nighttime errors. You can expect equatorial GPS errors even at midnight at the moment. This is typical of coronal high-speed streams as well. When we see low electron flux, we see many more GPS errors around the planet. Again, that's your total electron content forecast. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. The universe is not electric, but portions of it are. No, we do not refute the existence of Birkeland currents. By the way, that's one of the arguments that we get all the time when we say the universe is not electric. People say, are you suggesting Birkeland currents don't exist? No, nobody is suggesting Birkeland currents don't exist. It's a known thing. Nobody is refuting the existence of Birkeland currents. Continuing on here, here's our latest SDO magnetogram and our latest SDO intensitygram. So let's take a look at this new sunspot group. It is already beta gamma class. I see 2 clear umbrae there. One of North Pole orientation and one of South Pole orientation. So it's already beta gamma class. And whether or not it's beta gamma delta class is for us to determine at a later time because it's not risen high enough yet. So again, we may see a little uptick in the sunspot number here in the radio flux depending on how many more umbrae are trailing that group. It's at least 2 very large umbrae there. Certainly one nearly the size of the Earth. I think even larger than the Earth. There's your umbral to magnetic field rock back. We may have a new sunspot rising or forming down here as well. Currently it's just a plage. As you can see there, no umbrae yet from that region. So anyway, this brings us to our meteorology segment. And thanks for sticking with the video this long as we transition from the realm of Earth weather to the realm of Earth weather from the realm of space weather. So what we're looking at here is the total cloud water. This is always interesting. It'll show you, we've got surface winds animated as well there. So surface winds and total cloud water. This will be great at showing you low pressure zones, as you'll see a counterclockwise rotation in the northern hemisphere or a clockwise rotation in the southern hemisphere. And it'll show you all the different spots where we have large cloud cover, the total cloud water. Another great feature of nullschool.net. And let's briefly just switch to space here just to show the current conditions. High likelihood of major aurorae here, especially if we see those fields stay as strong as they've been. So a very strong negative BZ component and a very strong magnetic field as measured at Lagrangian point 1. Let's take a look at Earth's wind patterns. There you have a great clockwise rotation in the southern Indian Ocean, as well as in the Southern Ocean. Those are the surface winds of the eastern world. Here are the jet streams of this side of the planet. Here are the jet streams of the western world. Here are the surface winds of the western world, and it feels like spring in Pennsylvania, even though we should be in the dead of winter. Just coming out of the coldest time of the entire year here, seeing temperatures over 60. I saw 63 degrees yesterday on the automotive thermometer. Those are the surface winds of the west. And check it out, there's a high pressure system centered right on Bermuda. A great example of a counterclockwise rotating anticyclonic system. Clear skies over Bermuda. These are the surface winds of the central world. Shout out to our viewers from the west, from the east, and from the center. If you're viewing the video from a different solar system, galaxy, universe, plane of existence, planet, star system, spaceship, etc., leave us a comment and let us know all about it. These are the jets of the central world. And And let's continue on to our clouds and fog view for the Americas. So that is shortwave radiation, part of the infrared spectrum, showing clouds and fog. It's too dark over half of that map to use the visible satellite. We've got some violent weather in the east central U.S. We'll get to it. First, our weather.gov map will show you the key. There is the key. And by the way, the key to YouTube is not watching nonsense. And thanks for leaving comments, Mr. Bordages. So there's your weather.gov map. If your location's lit, click your location on weather.gov. We've got some winter weather warnings. So let's do some forecasts. Starting out with the temperature anomaly forecast. Since we've got exceedingly warm temperatures here coming to the mid-Atlantic states, we cyclists are delighted about it. So that's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Cold weather west of the Mississippi and warm weather east of the Mississippi, at least for the next 2 days. Dag, that is nice. Next, pressure and precipitation. We've got some ice. We've got some thunder snow perhaps happening, and some heavy, heavy storms. We'll get to that in a moment. That's your 72-hour GFS pressure and precipitation forecast. Here's your GFS total accumulated precipitation in inches, and some heavy rain accumulations expected there for Alabama, Georgia, Tennessee, Kentucky, and West Virginia especially. Some areas seeing upwards of 3 inches of rain there. And here is our total accumulated snow depth change forecast for that same period. The GFS 72-hour